So we are resuming the acid-base equilibrium, continuing onward where we kind of left off with the last segment. If you look at the standard method of expression for a Ka here, here's your acid dissociation constant. There are tables that give all of the number values for typical acids in the back of the textbook, as well as they can be found on Google. We've got the H plus or the hydronium part, this is the shorthand version of it. We've got the conjugate base part, and we've got the unionized part there. So we're going to pick on acetic acid. It is overwhelmingly the one that is dealt with the most often as being a weak acid. So if I write the equilibrium expression for something that's not a generic acid, for something that's actually a specific acid, we're going to put the H plus on the top, we're going to put the acetate part on as its conjugate base, and then we put the unionized version on the bottom here. So positive bit, negative bit, the part before it actually falls apart. One of the reasons that acetic acid gets picked on is the fact that it is a stereotypical weak acid. But what if you don't have a weak acid? Are there things that are strong acids? Strong has nothing to do with the molarity or molality concentration. A strong acid is something that has high dissociation. Basically, it means that pretty much everything falls apart. Usually you get approximately 100% dissociation or ionization. So we need to actually address the ionization idea. Ionization is something that can be calculated. If you want to do percent ionization, you can do it as the ionized concentration at equilibrium over initial concentration. Note, it says percent, so we've got to tack a 100 off to the end there. But back to the idea of what are the ones that are strong ones? What are the ones that are not weak acids? You will find that most textbooks will quote you 4 acids that are guaranteed to be the strong ones. They are ones that we are mostly familiar with. We've got hydrochloric, we've got sulfuric, we've got nitric, and then there's this 4th one that is a lot less common. This one was seen in 111, but we're going to revisit a little bit here, and this is known as perchloric. These are acids which fit this criteria of 100% ionization, meaning that they fall apart almost completely 100%. Stop.